everyone, this is Neelam Sondhya. I am a student of Software Engineering in International Institute of Professional Studies, DABB Indore. This is my fifth video. Uh, Today's topic is model evolution. We will go to the PPT. Okay, model evolution, mastering the art of model assessment. We will explore the essential techniques for accessing the performance of machine learning models. We will cover the key metrics used that determine the qualities of your model, equipment of your the knowledge, the confidently making information decision based on the performance. First slide, understanding understanding model evaluation metrics. There are four methods: accuracy, precision, recall, F1 score. Accuracy, the straightforwardness metric that measures the portion of correctly classified instances. It's suitable when all classes have equal importance. Means this is a straightforward measurement for the portion of equality or correctness. The second one is precision. Measure the portion of correctly predicted positive instances out of all instances predictive as positive. Ideal for scenario where false positives are underseparable. Recall, measure the proportion of correctly predicted positive instances out of all actual positive instances. Ideal for the scenarios where false negative are undesirable. F1 score, the harmonic mean of precision and recall, proving a balanced measure of model performance, useful when both false positive and false negative are costly. So basically this is the checking of false positive and negative and checking their desirable or undesirable. The next slide is about evaluating model performance with Python. How do we evaluate the model performance? Okay, import libraries. First one is import libraries, second data load, train models, predict outcomes or calculate metrics. First one is import libraries. Start it by importing necessary libraries like scikit-learn for evaluation metrics and pandas for data manipulation. Data load your data into Python data frames, ensuring it's properly formatted, and model training and evolution. Train model your chosen machine learning using the trained data. This step is crucial for building a robust model. Fourth one is predict outcomes. Use the trainer module to predict the outcome on the test data. This is generates prediction for the comparison with actual values. Calculate metrics. This is the last step. Utilize function from scikit-learn to calculate accuracy, precision, recall F1 score, and relevant metrics. And the relevant metrics is visualizing model performance. There are three steps: confusing metrics, ROC curve, or precision recall curve. Okay, first one is confusing metric, a visual representation of the model performance showing the correct and correct predictions for each class. This is confusion matrix, in which we visualize the model performance and showing the correct and correct predictions for each class. Provide insights into the type of error and made. ROC curve, plot the true positive rate against the false positive rate for difference classification. They are sold. Help in understanding the trade-off between sensitivity and specificity. The third one is precision recall curve. Plot precision against recall for different classification. They are sold. Useful the evaluating the model, thereby the precisions or recall. This recall it's prioritized. The next topic is handling unequal error codes. There are two types: scenario fraud detection or addressing imbalance. First one is scenario fraud detection. False positive flagging a legitimate transaction for fraudulent can lead to inconvenience of customer, but false negative missing a fraudulent transaction can result in significant financial losses. Addressing imbalance, utilizing technique like cost sensitive learning to the adjust models decision boundaries to penalize high cost errors more heavily. Cost sensitive learning in Python, there are three steps: define define weights, train models, evaluate performance. First one is define weights. Assign weight to each class, reflect the cost associated with the misclassifying it. For misclassifying it, for instance, assign a higher weight to the fluidant class in the fraud and fraud decision. Train model. The train model using the defined class weights. This instructs the model to penalize error or higher cost class, more class for strongly. Evaluate performance. Evaluate the model performance using the same metrics, but consider the cost implications when interpreting the results. Okay. Cost validation evaluation. There are three: data splitting, training and testing, training and testing, data splitting, training and testing, or averaging results. First one is data splitting. So divide the data into multiple folds. Divide the data into multiple folds, usually 5 or 10. This ensures the model is evaluated on the different subsets of data, preventing overfitting the specific portion. Okay. Training and testing. Iteratively train the model on all the but one fold and evaluate the performance on the held out fold. Repeat this process for each fold. Averaging result. Average the evaluation metric across all fold to get the robust estimation of the model performance. The key points of it is: first one is comprehensive metrics, Python implementation, cost sensitive, and learning cross validation. First one is comprehensively metrics. Understanding the strengths and weaknesses of different evaluating metrics is crucial for accurate model assignment. Python implementation using Python libraries like scikit-learn for the efficient calculation and visualization of the model performance. Cost sensitive learning. Consider unequal error cost when evaluating model and employ appropriate techniques to adjust decision or decision boundaries. Cross validation. Implement cross validation to obtain robust estimate of model performance, preventing overfitting and ensuring generalization. So this is all about the model evaluation. Thank you for today.